Do you know what lets us see what the universe was like 13.8 billion years ago? It has the same kind of radiation as that in your microwave. Plus, you may have caught some of it on your old analog TV. It's the cosmic microwave background. The cosmic microwave background, or CMB, is a radiation from 380,000 years after the Big Bang. It is present in the microwave part of the electromagnetic spectrum, so we cannot see it with our eyes. This is a map of the CMB as taken by the Planck satellite. The CMB is omnipresent, so technically when we look up at the sky, the CMB is there too. In the early 1960s, there was a lot of debate about the origins of the universe. Some believed in the Big Bang theory, while others in the steady-state model. The CMB is the biggest proof for the Big Bang theory. To learn more about the CMB, let's talk about the Big Bang. The universe started as an unimaginably small singularity which later rapidly expanded in the epoch of inflation. But no light could escape. It was still too hot for atoms to form, so photons would keep getting deflected by free electrons and couldn't travel a very long distance. About 380,000 years after the Big Bang, it finally became cool enough for atoms to form. Now the photons could travel freely. The universe turned from a dense fog to clearly visible light. This light is the CMB. But then, why can't we see the CMB with our eyes? This is because of cosmological redshift. Redshift is the increase in wavelength of light as it travels through expanding space. Think of it like this. When I stretch this band, the wave on it stretches too. Similarly, the universe has been expanding for 13.8 billion years. The light has gone from visible light to microwaves. This is an example of the Doppler effect. The CMB has fascinated us ever since it was discovered. That's why many satellites such as COBE, WMAP and Planck have been dedicated to research on it. The COBE satellite told us that the CMB has a perfect black body spectrum. A black body is an object that perfectly absorbs and emits lights of all frequencies but does not reflect any light. This is significant because this was predicted by the Big Bang theory, so it is further confirmed. In this CMB map, we can see tiny red and blue spots, hot and cold spots. These are CMB anisotropies. They were caused due to quantum fluctuations in the early universe. Quantum fluctuations are random energy changes in a quantum field. A quantum field is something that has a value everywhere in space. Quantum field theories describe particles as disturbances in quantum fields. These quantum fluctuations from the early universe expanded crazily during inflation and led to the formation of all the structures we know today, like stars and galaxies. The CMB has answered so many of our questions about the universe and is still an active field of research. So go out there and gather knowledge, because thirst for knowledge is what gives us magnificent answers about the universe.